Let's see, where did I leave off yesterday? So I think I wanted to well, okay, so I sorted them, and then I was iterating over the sorted vector, but this was wrong. So what I was doing was I was checking every time of arrival. The sorting allowed us to maintain position of each car in the correct order. I don't know what car this was, but it's irrelevant. The only relevant information is how far it is from the target and what cars ahead of it, what other cars are ahead of it. We wouldn't know what other cars are ahead of it unless we sorted it. And the reason we want to know what cars are ahead of it is because we also know for each specific car their estimated time of arrival, or how many steps it takes to get to the target. So the problem states that cars cannot pass each other. And if a car, let's say, for example, this first one, if a car it takes less steps to get to the target, then, and we can pass the car ahead. So for example, there's another car here. So this one takes 2 steps to get here to the target, but it can't do that jump because there's 4 other cars ahead of it. So this one will join a fleet. Let's see. I seen online that they were iterating, they had sorted them in descending order, and then they were checking if the time of arrival, so if they were in descending order, we would be looking at it in reverse. So we'll be looking at the car closest to the target. So let's see. If we look at this value, I'm gonna take 0 steps. That's not right. I think that's a miss. Which one is this one? It should be 1. I'm doing this with my mouse even though I have my iPad. Okay, so if we iterate through, we already have the sorted. We already have it sorted. We iterate through the sorted vector, and the sorted vector has these two values, its position and the time of arrival. So we could look at the second value. We'll look at the second value. Then, well, actually, okay, we'll start here, right? I'm not too sure how to do this. Would we use like a while loop? Let's say we have I, and I starts in this first position in the vector. So I is 0. Then what can we do? If I minus 1, meaning this one, is less than our current value, then it becomes part of our fleet. So at this point we have 1, the fleet is 1. And we check this value before it. And if it's less than our current value, it'll be part of our fleets. So then we can just do nothing and increment it by 1. Our fleet is size 2. We're not going to say that though. Our fleet is still 1 because these are equal. So if it's less than or equal to, then it becomes a fleet, meaning this car behind it, well, they'll reach the destination in the same amount of steps. But for example, let's see, for example, this one, it's 4. Car before it, or the car behind it, will reach the target sooner than our current position car. And so these will become 1. In this case, for 3, so okay, wait, so this one becomes a fleet. It's 1, and we can move I down by 1. We compare it to the car behind it. The car behind it is greater than. It'll take much longer than our current car to reach the target. So the fleet increments by 1. So now the fleet size is 2, which is this one originally. Yeah, so if the car behind it is less than or equal to our current car, then we do nothing. We just move pointer up by 1. If the car behind it is lower, we increment the fleet by 1, and then we can move. So in this scenario, the car behind it is slower, so we increment the fleet by 1, and then move to the next car. In this scenario, car behind it is less than, so it becomes part of this group. And we'll have three fleets. Let's see. So this one currently breaks. It took a long time to compile that. I think this is okay. It passes the test cases from the Leetcode problem, but when I submit it, it broke in other cases. It was just the way I was grouping them. So let's just kind of remove this. We're only going to need one. Actually, it's going to start at the last index. And we want to loop all the way till we reach 0, which is the beginning of our array. Okay, let's see. So we want to say if our estimated time of arrival if the car behind us estimated time of arrival is less than or equal to our current time of arrival, also Fleet's going to start at 1. Should it start at 1 actually? Let's see. Yeah, I was trying to pass this edge case. Wait, not here actually. In my submission, I cheated a little bit. Let's see, I think it was here. I did this weird thing where I just checked if the size was 1, then I just returned 1. I think that's fair. Probably a cleaner way. Did the algorithm catch that? I think it should. Okay, wait. We do we can increment by 1, can't we? See. Okay, wait. I'm trying to see if the algorithm catches, like if we set fleet to 0, does the algorithm increment this specific case that I'm looking at? So let's see. So fleet's 0. Okay, when we're here and we're looking the same time we're looking at this. So in this case, if they're greater than or equal to, so they're equal, so fleet becomes 1. Then we can move. See how I group this. Okay, so this one becomes 1 because 8 is equal to the time of arrival of our current one. So the condition is if it's greater than or equal to. Let me write that down. Okay, then the next one, the fleet becomes 2 because 3 is greater than, but 3 becomes its own fleet. Move to the next one. Four is greater than, so then we have fleet is 3. And we get here. We do nothing. They become, the previous car is less than our current car time of arrival, so it just joins with that car, so we do nothing. Okay, so it's greater than or equal to, we could increment fleet otherwise we do nothing, and then we could just increment I. I don't think we want I to get to 0 because we're doing I minus 1. Once it gets to 0, actually, will it stop once it gets to 0? Should, right? We could test it. Okay, and then we should have the correct fleet. Why don't we test to see if it passes the test cases that I already have on there? Yeah. Oh wait, I don't know why I incremented. I'm so used to doing. Okay, do it again. Okay, passes this one. I'm gonna look. I want the test case that it failed yesterday. I'm gonna submit this. Oh, I think I lost my streak too because I didn't submit anything yesterday. When I submitted this, does that count? No, I think I have to solve it, right? Okay, so just grab this. So I should expect 1. There's like a cert, I think, and we might not have to write all this. I'm gonna have to look it up because I can't remember how to write the test. It'd be much more. It might be much more efficient if I do it the right way. Let's see. Okay, so not really a unit test. Fair enough. I think I have G-test. Not really what I want to do. I think it's more of this. Wait, does this print on the console? Only when it fails. Do I have to include anything? And then what we're expecting, right? I think that was. I think it should equal 3 on this one. I think that one's also the same. It should be 3. And the next one should also be 1. I should write it first. I don't have the speed. Wait, the speed's right there. What am I talking about? And it's spelled wrong. Okay, position spelled wrong. And then Didn't catch it. There's something wrong with it. Wait, why is it wrong? What's the value? I should print it. Maybe I should just start printing it. Does it print 0? What? Why is it 0? Why is it 0? What was the example with 0 to 4? Okay. We have 25, 49, 96. We can sort them by position. We have 0. 0 gets there in 25 steps. We have 2 gets there in 49 steps. And 4 gets there in 96. And the condition that I was checking was if the value before it is greater than or equal to. Yeah, I didn't catch that initial fleet where everybody behind it is less than. So when do we increment the fleet? Okay. I think I'm gonna check my solution because I'm spending way too much time on this. Okay, there's a couple of issues. Integer division. I thought that was the intention. Oh man. Fleet counting logic is incorrect. You're only comparing adjacent cars once, but fleet information is cumulative from right to left. Sort cars by position, ascending. That's what I did. Traverse from the car closest to the target backwards. I'm doing that. Track the slowest estimated time of arrival seen so far. Current fleet time. If the car's time of arrival is greater than the current fleet time, it forms a new fleet. What if it's equal? Okay, so we had to change this to float to a double. We have to cast a double into this whole thing. I thought that was the point of the float. Okay. Target. Wait, am I doing the right thing here? That's fine. That's fine. For sorting, that was also fine. They're using a different type of loop. I think that's okay. Okay, whatever. Wait a minute. Fleet. Okay, fleet, and they need current fleet. That. Do we need fleet and current fleet time? Why do we need both? Why do we need both? Okay, so if the current car is greater than the fleet time, that's how we get rid of the zero. So we're comparing against fleet time, not the car behind us. Interesting. So we increment the fleet, but we also set the current fleet time to the estimated time of arrival of the current car. Oh wait, I forgot. I should not have done this. Yeah, so we don't need to do this. I should have done it on the other one. Jeez. Okay, we'll yank this one. Oh, but we only need this part here. I forgot I didn't paste what I was working on into Leetcode. So this part's the actual working one. Now I broke the other ones. Let's see, what am I missing? Oh, I didn't cast it on this one. It's supposed to be a double. What did I put equals to? It's like magic. Yeah, we're gonna copy this into Leetcode. I was already rubbing my hands together. Like I did something. paste it. You just run the debugger. We already know it fails. $77. Well, line 77 is the assert. We're just gonna run the debugger. What was it returning? It returned 5 instead of 4. Yeah, I think you can make it smaller. I can see those words crunched together. Yeah, we're gonna step into wait a minute. Why did it turn into 1.5? Wasn't it 3? That doesn't make sense. So here, I think it's the previous value. Okay, it has no value, I think, at this point. ETA is going to turn to 1.5. Okay, this makes sense. 1.5, 0.5, 1.6. frustrating. Was it not supposed to be? I mean, that's kind of what it wrote. It set it to 0. And then it set it to the time of the current car. What's it saying? Ah, it's a double. Nice. Can you stop this? It's like little things like that I just forget to think about. Thank you for not working. Maybe I should have read the rest of the chat. Right. I think it's just an issue with, should be expecting 4. I just wrote a bad test. Okay. Why did I use double and not float? I want to know that. Yeah, why not float instead of a double? It says the important thing is that the division happens in floating point arithmetic. So double has higher precision than float. Okay. Okay, so I created the data structure right. It was pairs of vectors where the first value was an integer and the second was a float. But then when I was calculating the estimated time of arrival, I was saving it as an int because I was doing integer division and it was converting the result from a decimal to an integer and sticking it into a float. which didn't throw an error, but we were losing position. That was a big one. Another one that was a big one was current fleet time. So we would initialize it to 0. And the comparison was if our current car's time of arrival was greater than the fleet time, which it would have been for the very first car we seen, then we increment the fleet and we change the current fleet time to that of the car. In the case where they were, and when we move to the next car, right? If the current car has, let's say, the same estimated time of arrival as current fleet time, which was the time of the last car, then we would do nothing. If it was less than, then we will also do nothing because it will become one fleet. It will catch up. Only when the current car's estimated time of arrival was higher than the current fleet did we increase the fleet time. Did we increase the fleet count and the current fleet time? Because now that became the slowest car to reach the target, and thus making a new fleet. I don't think this is, yeah, this is super slow. Let me see what's the time complexity that they wanted. I didn't take that into account. And log n. Sorting takes n log n, I believe. Or does it take log n? Yeah, I'm gonna look at the video. How does he use a stack to solve this?
Hey everyone, welcome back, and let's
Jesus. The volume's too high.
write some more neat code today. So today let's solve the problem.
Oh nice, no ad blocker. Just mute it. But I think
CarFleet. I think a lot of people don't end up solving this problem, but I think it's a very good problem and interesting problem to solve. So we're given n cars that are traveling along the same road. It has one lane. The road has only a single lane, and this is important for the rest of the problem. All the cars are traveling towards some destination, which is at some target position, right? And every car that we're given has a position and it has a speed associated with it. And remember, they're all traveling in the same direction towards the target. And the position and speed are given in their own arrays. So there's two separate arrays given for each of these. And the important thing is that a car can never pass another car. That's because we have one lane in the road, right? So imagine we have two cars like these. You know, this one's traveling and then this one's traveling, right? Let's say this one's traveling at 10 miles per hour and the other one is traveling 20 miles per hour. Of course, the faster one is eventually going to catch up to the slower one. But since they're in the same road, even when they do catch up, that faster one is just going to be traveling right next to the slower one, right? So the slower one was traveling at 10. Once the fast one catches up, its speed is going to be reduced to 10 because it can't pass the one that's ahead of it. So once cars are basically traveling right next to each other, that is called a car fleet. And by the way, if these cars are right next to each other, they're basically assumed to have the same exact position. Even though technically one is behind the other one, they still are considered to have the same position. That's what they mention right here. And they also mention a car fleet is just some non-empty set of cars that are basically at the same position, traveling at the same speed. And by the way, even a single car can be considered a car fleet. And the last edge case you might be wondering is what if a car catches up right at the moment that they both arrive at the destination point? Because remember, once they arrive at the destination, they're going to stop. So what if a car catches up exactly at the destination? Well, they're considered a car fleet. And what we want to do is determine the total number of car fleets that will arrive at the destination. So
Okay, I've seen that already. I just want to know how he uses a stack. See, he talks about it right here.
we don't even know what speed the blue one is going to be traveling throughout the whole thing. We can't just assume it's traveling at speed 2 the entire time because it could collide with somebody else and slow down. That's why it's better to start from the right and then iterate through this in reverse order. Okay, now just to complete the example, so we know that this is going to end up colliding with this one, so we can just assume that this car is a single car fleet. We have one more car over here and it's traveling at speed 3. So now we want to know, is this one going to collide with this one? We already know what time this is going to reach the destination. Let's calculate the time this is going to reach the destination. So we can do 10 minus 3. So that's 7 divided by 3. That's going to be 2 point something, right? Let's just say 2 point. I think it's 2.3 or something, but it's not too important. But we know that this, since it has a smaller time than the one ahead of it, then they are going based on the position how we're going to be doing this. Just to mention, the overall time complexity of this portion of the algorithm where we're actually going through the cars is big O of n, but of course we know we actually have to sort the input based on the position, so that's going to make the overall time complexity end up being n log n, and the extra space is just going to be big O of n. Because we're going to be creating a separate array, but we're also going to be using a stack just to give you a preview of how we're going to be doing this. So just to let you know, initially our code. Okay, now I'm just going to iterate through both of the position and speed array simultaneously. I can do that with zip, but you can, instead of using an array of pairs, you can also just have like a hash map or something and then just sort the positions if you want. I'm doing it this way because it's easiest, but you can do it how you'd like. This is, I think, called list comprehension in Python, if you want to Google it. We're just creating an array of pairs, but next we don't want to forget to actually sort that array of pairs. So when we go ahead and iterate through that array of pairs, p position and speed in sorted pair, and so we can iterate through this sorted, but we also want to make sure we iterate through it in reverse order in Python. That's pretty easy to do, just like this. So just to clarify, what we're doing is reverse sorted order.
Dude, Python is horrible. The length of the stack. Okay. I'm gonna look at other people's solutions. they? Where are they? Submission. Yeah. Okay. Look at some of the faster ones. What does back do? Like a different one. They don't do the same thing. Gets quick sword in here. Okay. Do a different problem. Next. Did I miss 2 days? I have no more hearts. This should count as a submission right here. Like, at least I was here. Like, Drake should keep going. I have to solve a problem. Should it make my life harder? Last time I tried to do binary search and that one took forever. Linked list. I should be moving much quicker than this. Sliding window. I think I used the sliding window in one of the other like subsections. There might be overlap some of these questions, like in the way you can solve them. Best time to buy and sell stock. I think I've seen this one before. Yeah, I solved it. Let's read it. I'm gonna add it onto my notes though. Give me 1 second. I already had it on my notes. Nice. Okay, let me add a sketch. I'm doing this thing where I'm whiteboarding now, because at least if I can't solve the problem, I get some time drawing. Because I haven't drawn since summer started. I get to do some shapes. Let's see, you are given an integer array prices where each index is the price of the neat coin in the ith day. Okay, so the index itself is the day, but the value at that index is the price. You may choose a single day to buy one neat coin and choose a different day in the future to sell it. Return the max profit you can achieve. You may choose to not make any transactions, in which case the profit would be 0. Okay, let's look at the example. You put a timer. Do 15. I'm gonna do 30. That's gonna include like whiteboarding. That might be too much time, but whatever. Let's see. Oh, I'm gonna copy this example and put it on the whiteboard. So it says these are the prices. The max profit you can make is 6. If you buy at index 1, you'll pay $1, or you'll pay, let's just say dollars. You pay $1. And if you sell at index 4, you just take the difference. So you kind of keep a count of the highest number you've seen. That's it. I'm gonna take this example. Open the whiteboard. Okay. So okay, we need like a current price. Could be like super small or something. Do we have to have it super small or super big? So we're gonna say lowest price is gonna be equal to like a really big number, and the opposite for highest price, a really small number. Okay. We can iterate over prices and we check if the current value is smaller than our lowest price. So 10 is smaller than infinity, so then this will become 10. But we need some way to store pairs or something, so we know what index it was in. Or we could push it into like a map. It says sliding window, so I'm thinking okay, hold up. Let's keep going. So 10, and then we can move up by 1. Jeez. Am I clicking on that? I don't think so. Why is this thing always such a headache? Okay, we'll move it down here. Can I click on this now? Okay. We'll do it like this. Okay, next one. Oh, and this would also be 10, I think. Lowest price will update to 1. And highest price would stay at 10. I'm gonna link these. Okay, nothing happens there. Nothing happens there. Nothing happens there either. But it has to be in the future, so this doesn't make sense right here. Okay, let's try sliding window. We need like another one of these, I think. Changes color. Okay, we'll start at 10, and then the other one starts. I guess what we can do is we can say, we'll call this I, and then we'll call the other one J. You have all the time in the world. I should save this as an image. Like I always use pointers. I have it as a stamp. Use it again later on. Okay, so we can move J until we find a value greater than I. Or actually, we would also need a variable to hold the highest value. So we can say like the highest value that J has seen. I think that's the case. So we could say highest price equal to negative infinity to start. It'll start here. So negative infinity would turn into 1, right? Then 1, obviously, is less than 5. So highest price changes. Then it'll change again. It'll change at 7. So it'll change at 6 and it'll change at 7. But then once it gets to the end, so when J is pointing at last value in prices, highest price is 7. It won't change to 1. And we can take the difference. We can have something like this. I think we put it in a map. or a stack. Or a set. Also, maybe the highest price should not start at negative infinity, but 10. Because we want to turn a profit. And in this current case, right, we would have a negative value when we do 7 minus 10. Because we sold at a lower price than when we bought it. So let's see, how does that look in practice? We can say is equal to 10. Then when I looks at each value, you'll realize that none of the values that it's seen are greater than 10. So none of them would generate a profit. So because we can't generate a profit, we don't do anything, and then we can just move I up and then J restart. The highest price here would be 1. Then when we look at J, it instantly changes to 5. And just imagine we can move J all the way to the end. Each time evaluating the highest price versus J's price, so it changed from 5 to 6, then to 7, then it gets to the end, and 1 is obviously not greater than 7, so nothing happens. In the profit, we'll need like something to hold the highest profit. So maybe like I'm trying to think. Just a variable I think it would do. The only problem is that we need the index too. That's why I was thinking of a map or a set or something. Wait, do we need the index? Actually, we don't. I don't know why I was thinking about that. I think there's another problem where they ask you to return the index, in which they're like, I'm trying to think what problem that was. Where they want you to calculate something similar to this and then return the index that gives the result, like a target result or something. Okay, irrelevant. We don't have to worry about that here. We can do highest price variable that stores the highest price we've seen so far. If the highest profit is negative, kind of like when I was 10, we couldn't find a value that was greater than 10, then the highest profit, I think highest profit starts at 0. Because the question also says, like, if you cannot find the highest profit within the prices array, then just return 0. So eventually we'll just want to return high profit. So we set it to 0, it kind of solves that issue for us. Anyways, let's see. So if I move now, okay, we have a highest profit so far. We have 6. Okay, also when J reaches the end, highest price is then reset again to whatever I is. It's always starting condition. So here will be 5. And then instantly J is greater than 5. So we'll have 6. think we also always have to calculate we have to compare the highest profit to, let's see. So we have to update highest price. We do the difference, so 6 minus 5 is 1, and we compare that to our highest profit that we have so far. The problem is, what's on the screen, best time to buy and sell stock. It's on Leetcode under the sliding window. But I could look it up to see what problem it is on Leetcode. Oh, number 121. I should probably put it on there. Okay. We can move down. Yeah, and we'll need to do this math too, I think. I think it's relevant. Because in the case that it's higher than the highest profit, then we have to change highest profit to that. I think that's it. Maybe I'm missing something, but we'll try it. We have 15 minutes left, so. And then I guess we could also see the, okay, we'll look at the hint if I get stuck, so. Okay, we're gonna use int price profit. It's gonna be set to 0, and then we do current price, highest price. Highest price, I think it's a better descriptor. Highest price. That's gonna equal to, I'm gonna set it to 0 for now, but it's supposed to be equal to whatever I pointer is. I think I also have to do like is equal to 0 and j equal to something like that. So then highest price is going to be prices at whatever I is. I think this happens inside the loop. Oh, I'm not even showing my screen. Okay. Nice. I'm looping until what? To the end of prices? I think that's it. What's the time complexity they want? I didn't even look at that. Oh, then. Wait, what? You can do this in OVAN? Yeah, I'm gonna look at a hint. Hint 1. Okay, that's what I was thinking about in the whiteboard. You technically have I that's gonna run all the way to the end of prices, but then you also have J that's checking every price ahead of I. So technically you're doing, yeah, you have to do 2 for loops. Okay, we're not gonna go with that one. Hint 2. Okay, wait, let's go to the whiteboard again. I think what I was thinking about before might work. Let's just take J out of here. So can we have like low and high? Where low will start at a really big number, and then high at a really small number. And as we iterate through the array, if we find a smaller number than the smallest number we've seen, okay, it kind of worked, but it got stuck with, it was not like looking in the future. I think it was the highest price got stuck in the past. So we could fix that issue. I think we could solve it in OVAN. Okay, how can we solve that though? So let's say we start with I at 10. 10 is not higher than infinity. So it's not our new low, but it does become our new high. Okay, then we move to 1. So it becomes our new low. But then you see our high is stuck in the past. The only way we would know it's in the past is if we knew its index. because then we could kind of do like an index comparison. I got 6 minutes. Yeah, if we keep going down this prices array, then eventually it'll stay like this, where the low is 1 and the high is 10. But the real high should be 6. And obviously the reason it stays like this is because 10 is the highest number in the whole array. So what I'm thinking is maybe if we can find a way. Also, I think space is O(n), so we can copy this into a table. Let's see. Could we do something? So the key is going to be the price itself, and the value is going to be its index. We can iterate over the table. Let's build this. And turn it this way. Okay. Okay, but this one still holds. So right here, we'll take these off. I think we'll be able to do a better comparison if we have a table. So high becomes 10. Then we can move to the next value, like this, right? Low becomes 1. Oh, but we also have to do, well, the comparison, right? So let's go back to the index comparison. So if we find a new high, okay, we'll do, okay, with 1, we'll check, is 1 greater than or less than low or high? No, it breaks. I think we're cooked. Okay, I think I'm gonna stop there. But we'll come back to this one tomorrow. It's part of the sliding window section. Best time to buy and sell stock. It's an easy. And I solved it before. I guess it's not that easy. But yeah, I'll try that one tomorrow. But for today, I think that's it.